Hello everyone. In this video, I will walk you guys through the different types of multicasts, what a join and gather combination can do, and what a router is, followed by hands-on demo on the above topics. Let's get started. What is a parallel multicast? So parallel multicast is a component in CPI that helps to send the incoming data to different branches. We use parallel multicast when the target output need not depend on each other and can function independently. Let's see how this works. First, the message is sent from the sender to CPI and into the parallel multicast. Parallel multicast uses this message and it creates duplicates of that message. In our case, it creates 3 duplicates as we have 3 branches. Then it sends all 3 messages to the next steps. I just have one content modifier here, but in your case, you may have multiple other transformation steps along each branches. So parallel multicast pushes the messages to subsequent transformation steps along each branch, and the output message that is created is then pushed to the output target systems. Now let's see what a sequential multicast can do and how it is different from the parallel multicast. In sequential multicast, the message is pushed from the sender system, or in this case, it is maintained in a content modifier. So it is pushed into the sequential multicast function. Sequential multicast consumes this message and it creates 3 duplicates because we have 3 branches here. If there are multiple other branches, then it will create a duplicate for each one of those branches. Now, this is the crucial part. Sequential multicast first pushes the first message to the subsequent transformation steps in the first branch. And then the output message from that branch is pushed to the target receiver. Once the receiver receives the message successfully, then sequential multicast pushes the second message to the subsequent transformation steps, and the output message again is pushed to the second receiver. Once it is successful, then the third message is pushed to its transformation steps, and the output message is then sent to the third receiver. Let's see what a join and gather function is. Be it parallel multicast or sequential multicast, when there are multiple branches involved, and if there is a case where you want to join or combine all the outputs of each of these branches or a few of those branches, we bring in the join and gather combination. So what is join, what is gather, and why do we have 2 of these for this scenario? So join is basically a component that is just used to bring the messages from different routes together. It does not affect the content of the message, but the actual gathering of the message or the actual editing or combining of the message happens in the gather step. All the messages that are brought together by the join step are combined using different available algorithms by the gather step. During the demo session, I will show you the different algorithms that gather is capable of combining the messages with. Let's quickly see a working model here. So the message is sent from the sender to our multicast, and multicast creates duplicates of the same message, and parallelly it sends them to the subsequent transformation steps. And these transformations produce output messages. These output messages are then pushed to the join step. And what join does is it just combines them together and pushes to gather step. And gather, on the other hand, using the internal algorithms, it creates a new message altogether. And then it sends the combined new output message to the target system or to the next steps. Now let's see what a router is. The router function is similar to any if function that you have used in your experience. Let's see how it works. So on the left, you can see a payload that I have maintained in my content modifier body. It contains 2 records, one with genre computer and the other with genre fantasy. Now I'm going to push this message from my content modifier to the router. On the bottom of the screen, you can see my router configuration. In this router configuration, I tell CPI to look for a field called genre and see if the field has the value fantasy. So the router looks for this condition, and if it finds this field and this particular value, then it sends the entire message via route 1. If the value that I maintained here in the condition expression field is not present, then the router pushes the payload through the default route that we have maintained, which is route 2. I hope you guys learned something useful out of this video. I'll see you guys in another video. Thanks.